All right, I just paused the video to check something. Look at this right here. I would like to do one more step before I move into here. Look at this, guys. Look. Easier thing to do. Don't do a hard way, Mr. Dan. Look at this right here. All right. Now, before I solve for k, can I divide also because they both have a common factor of e to the 2k. So I divide both sides by e to the 2k. Divide both sides by e to the 2k. You see it? And that is out. So what I have right now is same base, exponential quotient, subtract them. So you got over here is e to the, that's right, 2k equals 3. Make sense? Now I take ln both sides. Take ln both sides. So ln both sides, this will give me 2k, and this is ln 3. There we go. So right now, your k is what? K right now is ln 3 divided by 2. That's your k right there. Okay, you see that? So now you have k, okay? So all you do right now is just plug in, and what you are looking for is looking for c. Can I erase this? And you can pause the video if you want to. So here we go. All right, so now you have everything you need, okay? So you have right now as y equals c, okay? And e to the what? That's your, this is when you plug into your calculator, you will have a what? 0.5493. 5493. That's equivalent to it, okay, guys? So now all you do right now is just plug in, and that is 0.5493 t. That's t. So you now have the value for k, okay? And then simply you are now going to ask for what is c. If at the initial condition, time is what? What is your c? At the initial condition is t0. So just simply plug it in. You will have your victory, which is right now, you will have is what? Okay, you will use right now and apply for c. You can solve for c right now. Let's use the point right here. Use the point right here. You are going to solve for c, okay? So the point right now you are solving is using this point. Y is 100 equals right here, c, okay? E to, let's see. You have right now is 0.5493 times with 2. Okay, if you use 2 right there, you will have what? Here we have, I'm solving for C, okay? I'm solving for C. You using the given point, because I don't know, that's what I'm looking for. So look, using that point right there, you now plug it in, okay? Using this point or this point, either one will give you what you need, okay? So now you have, and solving backward, guys, solving backward, you have now, using punch in your calculator, then C equals 100 over e to the 2 times that, whatever that is, okay? 0.5493. There we go. Okay. Punch in your calculator for me, would you? When you punch in the calculator, you will have about, wow, 33 flies, 33 fruit flies. All right, that is equivalent to when t0, which is you plug in, you should have that too. Okay, guys? All right, that makes perfect sense. When c equals 33, this is when t equals 0, and you can see that. Plug in 33, t0, and you will have at the point of that, it is 33. That is the answer for you right there. Okay, that's an example 4. All right, now I'm moving into example 5 for you. Okay, example 5, shall we? All right, here we go. Example 5, you have a declining sales. Okay, all right, similar to the problem. It's not growth, but it's decay. Y equals C e to the kt. All right, from the given information, you know that the sales right now drop from 1,000, okay, sorry, 100,000 units. 100,000 units when T is Drop from, so they go for 0, okay? Drop from per month to, wow, to y equals 80,000. When t, which is, let's say, how many months after that? From month per month, okay? If it says from right there. So from that to that, if the sales exponential decay after 2 months, after 2 months. So there we go, t in month, okay, guys? T in months, okay? So from the initial month, which is month 0, you got 100,000 units. But then after 2 months, it go down to 80,000. So the question right now is, okay, if the sales follow this exponential pattern of decline, what will they be after 2 months? Whoa, what will they be after 2 months? Okay, so if the sales drop from, okay, all right. So let's go. Let me read the problem. Read with me. Is it the 4 months after? Oh, I see, 4 months after it drops. Sorry, guys. 4 months after it drops. So after 4 months, that's why I saw something not right. After 4 months, it dropped from 1,100 units to 80,000 units. So if you keep following like this, how about another 2 months? If already 2 months and go for another 2 months, which is when t is what? 2 plus 4, which is 6. When t is 6, then what is the new dropping, units? There we go. You have to, label them correctly so you can solve for them. So technically right now, you are going to solve for, again, you solve for C and you solve for K. All right, let's go for C. Y equals C e to the kt. All right, first one, let's go for C. That's the initial. When t is 0, you got what? You will got 1,100 equals C, and that is 1. So C is right there. Got it? Now, using this C to find K. Okay, so you got right now what? C is right here. So you got Y equals C is 1,000. Got it? 100,000. E to the K. And what's your T? T right now is 4. There we go. Okay? Got it, guys? All right, solving for this one right here. Solving for this one right here. But we know that when T is what? When T is 4, what is the dropping units? And that is, you see what I'm saying, right? When T is 4, you have what? 80,000. Okay, and simplify the 0, you will have that right. Oh, just Mr. Dan, you got 10 over here. You got 10 over here. Okay, there we go. So now you have what? Divide both sides by 10. You will got 0.8 equals e to the 4k. Take log both sides, you will solve for k, which is k right now. Take ln both sides. Okay, you will have the value for k, which is a negative value, which is negative point, okay, 0.558. 0.558. So there we go. That's the value for k. Now you have the value for k. What do? Well, if you know for k, you can plug everything in right now. So y right now equals what? You have C is 100,000, okay? And e to the what? You see that on the, okay. E to the what? E to the k. K is right here. Negative 0.0558 times with t. T right now is what? 6. That's what you're looking for, right? There you go. T right now is 6. Then you plug in your calculator, you will have y equivalent to, which is right now after 6 months, you will go down to 71,500 units. There you go. It's self-explanatory, guys, in example 5. Now I'm moving into a very beautiful example, and that is the Newton's law of cooling. Okay, example 6. So far, I haven't done an example on separation of variables. This is it. Okay, let's move to example 6, shall we? Example 6, you will see the beautiful of Newton's law of cooling. A heated object, when you place in a constant room temperature, then their rate of change will be will be proportional to the difference of the heated subject minus the room temperature, the room's temperature. So here we go. You have example 6, and that is right now, an object that is, you have this right here, an object that is heated up, and it is proportional to the proportional to the constant time the heated object minus with the room temperature. Okay, so that's the concept you see right now. Let Y be the temperature of an object, okay, heated and put in the room. And then the rate of change of that subject will be proportional to the difference of the heat of that subject minus the room temperature. Now, question from given data. We know that it cools down from 100 degrees to 90 degrees, okay? From 100 degrees, and that's the Y, it takes how many? It takes T equals 10 minutes. Make sense? Okay, so let's see right here. It cools down at the T equals 0. That is the object 100 degrees. But then when T is 10 minutes, the object is what? 90 degrees. Again, we're talking of the rate of change of different, the curve, it's now is a curve, not a linear function. So that the slope, the rate of change is different in every point. So at the initial condition, which is when T0, you got 100 degrees for that object. But then after 10 minutes, it goes down to 90 degrees. But then the question right now is how long, let me see, how long will it take when that object is measured of 80 degrees? That's it. So your job right now is to find what is the time. Okay, got it? What is the time that goes down to 80 degrees? So from this given information right here of Isaac Newton's law of cooling, you are now solving for Y. Okay, solving for not Y. Of course, you solve for the function, but seeking for the T, time. Okay, got it? Shall we? Let's go. Here we go. I am now using the concept of derivative, which is dy over dx equals k, and this is y minus 60. Okay, all right. It is important to set the condition. Of course, the object itself will be in between right here, which is starting from 100 degree heated and put down in the room and not go lower than 80 because you want to measure at that point. Okay, so that's the condition. Now, guys, you are very familiar with this, but instead of dx, can I put, guys, we're dealing with time. So what is this? dt. Make sense? Here you go. You are no stranger for this guy. Make sense? Let me give my board space so we can solve this one. Okay, here we go. All right, there we go. Look, I'm going to separate my variable. The y will go with the y and dt go to k. So this one now have what? dy over y minus 60 equals what? dt and time k. There we go. You see it, guys? There we go. Okay. All right. Now, can I solve for y? Yeah. I am going to just what? To get rid of the derivative, what do? Antiderivative. There we go. Antiderivative. Okay. This guy is easy for you already because it's a constant and dt. So the right side over here, you can tell right away. The right side is what? kt plus c. Okay. All right. So the right side is kt plus c. The right side is kt plus c. That's the right side. What we're talking about right now is the left side. It's a little bit challenging, but it's not that hard. You have now in y variable, but then you have a function underneath of that function, a quotient right here. So you let u, look right here. I'm solving this left side. Call it a. Solve for a. Left side, let u equals what? Y minus 60. So du equals what? The derivative of y is just what? Yeah, just 1. So you got dy. So let u equals y minus 60 because I want to put this in one entity. So now I convert everybody into u derivative. So I can just look on my left side right now turn into 1 over u du. You see it? My limited space. Look, let u equals y over 60. You are no stranger to that. So now the rewritten this guy, you will have du over u. That's it. That's what it is. And you take derivative of this guy will give you, that's right, which is ln of u. But u is what? Yeah, u is right here, which is y minus 60. All right, which is y cannot be less than 60. It makes sense. All right, cannot be negative. So there we go. So the left-hand side, this is what you have, okay? So this is your left-hand side, and this is your right-hand side. And they both equal each other. And you are solving for t. So here we go. Left-hand side is ln, okay, y minus 60, okay, parentheses, or absolute value, just understand that y cannot be less than 60, okay? So this equals what? Kt plus c. Okay, anyone sees that? Now I'm solving for t. I want to take this one off the ln. What do? Take e both sides. There we go. You guys see that? Take e both sides. So take this, both sides, you got now y minus 60. And this right now, look, the formula, e to the a plus b is e to the a times e to the b. So that means you got e to the kt times e to the c. But e to the c is what? Is c itself. Okay, so just a big C times with a big C. There we go. That make any sense? So technically, you now have what? Y equals, I bring 60 over. So that's 60 plus what? Plus C e to the kt. Okay, my handwriting. There we go. Okay, now, ladies and gentlemen, you now have this guy right now. You're almost home. You are now looking for, oh, what is t? When what? When the object is cool, the object cools down to 80 degrees. I need to know what? C. There we go. I need to know C and I need to know K. How do I know that? Using the given information. Shall we? Can I erase the board over here for you? Okay, so here we go. So this is your function, your solution so far right now. You got that right there. Okay, got it? Now I am going to solve for the value of C. And then I need to know what is the value of K using the given information to solve for C. Okay, solving for C. Using t equals 0 and y equals 100 degrees. Let's go. Let's solve for C. Okay, y is 100 equals 60 plus C. When t is 0, wow, that's 1 right there. It is, sorry, it's 0 right there. And that will give me 1. Got it? And then that means C equals what? Wow, C equals 4D. C is 40. Okay, got it? Now you got C is 40. Okay, so your function getting better now. Look, y equals 60 plus 40. E to the, what? Kt. Well, you need one more. That's K. You need to solve for K, so you can just plug everybody in. Solving for K using this guy right here. There we go. Okay, solving for K. Let's go using this point. And now you have what? Y is 90. Okay, y is 90. And you got 60 over here plus what? 40 e to the K times T. What is your T? T is 10. There we go. This is a very yummy problem. All right, let's solve for K, shall we? So bring this over here. You got what? 30 equals 40 e to the 10K. Again, divide both sides by 40. You will have what? 3 over 4 over here. Okay? 3 over 4, and then you got right there. And take ln both sides. Take ln both sides, you will have, which is K equals what? L on both sides, you will have K equals, which is here you have is the, take L on both sides, okay? I will not do that in calculation. So plug in calculator, you will see a negative value, which is 0.20287. There we go. Guys, you now got K. If you know K, can I plug it in right here? Okay. K right now is negative 0.02877. Okay, guys, the task is now almost done. All you do right now is, well, what is time? Sorry, missing T. Okay, what is time when y is 80? Plug it in. All you do right now is just algebra in an advanced level. Okay, so all you do right now is just plug it in. What is t when y is 80? So you have now 80 equals 60 plus 40 e to the negative 0.02877t. There we go. That's your guy right there. Plug it in. I'm going to bring this over here, and then you will see. And then you solve this for, divide both sides, you got 20, and then 40 e negative 0.2877t. Divide both sides by 40, okay? You got 1/2 over here, e to the negative 0.2877t. All right, now what do you do? Take ln both sides, solve for t, you got t close to, and that is 24.09 minutes. Guys, that is beautiful. And that concludes our chapter 6.2. And I will have homework for you there. See you next video, guys, or next week.